All right, everybody, if you're just now joining us on this webinar, this is our virtual roundtable. We're going to be focusing on glycol dehydration. We will be touching a little bit of other forms of dehydration, but mostly focusing on glycol dehydration. So to get started on this, there's four main areas that you can see this. So if something goes wrong, I know a lot of people are working from home, internet goes out, kid walks in. What we're going to do is we're going to be downloading this and then, of course, uploading it to our YouTube channel, our blog. So if you just want to do like a transcript and just do a quick control search, find out exactly what you want, we're going to be posting the transcript along with the video as well so that we can jump to that. I want to introduce the speakers. My name is Cameron Croft. I'm the CEO of Croft Production Systems. I'll be playing host today for the webinar, and then I got my Director of Engineering, Chris Smithson, to be joining us. So Chris Smithson runs the engineering team for Croft Production Systems, which is a natural gas processing company, CO2, H2S rejection, dehydration equipment, JT recovery and knockout. And then we got Jesus or Jesse Olivares going to be joining us. He's CEO of O Synergy. So he's worked for several companies in the past, project management, engineering, manufacturing, and then so we utilize him quite a bit, especially on the ASME code. He's a genius when it comes to that. His son and his team that he's put together is fantastic on that. So he's going to be joining us today, focusing on manufacturing perspective, longevity, equipment perspective. And then we have Terry Nelson, who's the manager of technical services for WPI. He's been helping, kind of leading the charge on that, building that division out, TEG services, dehydration, clean outs. He's come a long way over the last few decades. So anytime we have any glycol issues, TEG issues, or even processing issues, I like to call Terry because he has a wealth of knowledge and a lot of funny stories to kind of set the point across. So he's going to be joining us today and kind of leading the charge on a lot of these conversations. So today, in today's outline, we did reach out to quite a few people trying to figure out what are the big issues that we're seeing, and we narrowed it down to four common denominators. One of them is winterizing, making sure the glycol system is functioning in that, maintaining glycol maintenance, what is proper maintenance, efficiency gains and filtration, and then the fourth one is emission controls. So to kind of get started on this, to discuss the roundtable structure, everyone that's joining us as an attendee, this is your time. If you have specific questions that you want to kind of go or kind of elaborate the conversations, we're just going to allow the conversation to keep going, but please put in there, I opened up the question and answer and the chat function. You put in what you're looking for, any questions to elaborate on, and we're going to be answering that as we go. So the focus on today is the natural gas contaminant is the water vapor, of course, is dehydration. So in the first topic that I want to discuss, or the common denominator, is winterizing. So what I want to do is kick off the question of what are the main things that you should be looking out for, especially in Texas. Like this is a picture of South Texas. Doesn't look like it, but it's during winter. So because we get hot, it hits 80 degrees in the day and then drops down to 30, 40 at night. So there's always that huge volatility of temperature ambient swings. So I mean, what would y'all look out for in this? What are the failure points?
Well, you're going to have a lot of condensate fall out. Your fuel gas system, you've got to keep that fuel gas pot drained constantly. You got to always check your fuel gas system because temperature changes at nighttime. You'll get a lot of distillates in your fuel gas, and that can cause everything from, you can see that the top of that steel column is so black, it's a lot of soot. So evidently there's a fuel air mixture problem with that burner system. They need to address. Part of our winterizing that we go through at WPI with our customers is burner checks, where we get that burner, take it apart, clean the burner out, clean the flame arrestor, and if it has a burner management system, make sure it's functioning properly. and, you know, make sure the pump is running. A Chemray pump puts off so much waste gas that it has to be functioning properly, or you'll have a lot of excess pressure on your pump gas separator, your flash tank, and it'll cause issues. And one of the things is the color of the glycol in that sight glass. I can't see it from here, but I assure you it's black, and it's showing because it's hydrocarbon contaminated.
Yeah.
Yeah, I think the pump gas separators, like this one doesn't have one, but if it did, like a lot of them, since they don't normally make any oil in the summertime, if they're not catching any condensate, there's nothing to skim off. A lot of times, like we see people plug them, or they don't pay attention to make sure the level controllers are working. And then, you know, when it actually does need to get used, when it finally starts to get cold and you start catching some condensate in the tower, then the system isn't working right. Dump valve may not be operating correctly, or the level may be set wrong on the separator. Especially the smaller flash separators, sometimes they can be a little trickier to set the level controllers on.
So right now,
Yeah, I will probably add just.
Sorry,
I'm sorry.
Jesse.
I will probably add just make sure the insulation is properly sealed, and this one seems to be in decent condition. But make sure you holding on to all your heat and not just losing heat here and there. Terry and Chris already mentioned a few of the other things, especially if you're not changing filters and what have you, then all that is just going to, like Terry mentioned, contaminate your glycol, and therefore your system is going to be operating a lot more than what it has to. Maybe fuel system, just making sure. Most of them nowadays, or all of them, should have like a preheat into your fuel system to make sure you don't get any condensation in your fuel, and then potentially this might be some of the issues out there, or what you're seeing up there too, where you're having a lot of flashing, and therefore yeah, that's what you see burning up there too.
Chris, correct me if I'm wrong. There's one time that I don't know what type of insulation they utilize, but with the temperature swings and it would heat up, drop down, the insulation around the reboiler started condensing and got wet, and then almost became a conductor, right? I mean, it wasn't insulating at all. It just got all soaked.
Yeah, we've taken them apart before and found that the insulation was pretty wet, which, I mean, that's just a bad seal on it. Like a system like this one here with no flash separator, I mean, you have a pretty consistent coverage. You worry a little bit about where the still column is, as far as like where your insulation might be, especially how they put that neck of insulation around the still column. Sometimes that can stretch and wiggle a little bit, and then if you get water in there, it could be bad. But a lot of times that foot where that flash separator sits on the smaller reboilers, that area that silicone can break out, and the water starts to get in there. And once you get water in there, the insulation, the high temperature insulation is like a fiber material. So once it gets wet, unless it dries out, it just loses all of its insulation value once it actually gets wet.
All right, so the big thing that y'all are saying is during the winterizing, especially the temperature swings, is the liquid hydrocarbon fallout. You're going to start seeing a lot more of that. Right?
Yeah, and most people will start turning up the methanol in wintertime too. And glycol units, because they're taking out the water, the methanol will get absorbed into the glycol, which is a problem that we don't see with our PDS systems. The methanol goes straight through them, which actually creates issues reading the tubes on the back end. But because the glycol system is absorbing the methanol, if you have a charcoal filter, then the charcoal filter is going to absorb that methanol too. So if you may see increased foaming issues in the wintertime, and it could be because the methanol is getting absorbed by the charcoal filter, and the charcoal filter just has no more capacity to be able to absorb the other hydrocarbons that may be causing foaming. I don't really think methanol, Terry, you might know better, but methanol isn't really a foaming issue that you may have in the reboiler. It should just boil out and vaporize. But I mean, really anything, I guess, it's vaporizing is a potential risk of foaming.
Well, this unit here, it wouldn't be a problem because the methanol would flash off and it would go out to the atmosphere.
Yeah.
On a closed system where you'd have a BTEX unit, the methanol will increase, it'll be increasing the flash, so you can have a pressure build up in the system, and it can actually cause a buildup and have some relief valve issues. But normally it's not that much, depends on the use of the methanol. Some people don't know how much they're injecting, and they just crank those pumps up and they're just dumping methanol in there. And what people have to realize too, those Chemray pumps have no lubrication. They're lubricated by the glycol going through them. Methanol and hydrocarbons are not lubricants. And the more your percentage of glycol drops, the less lubrication you have on those pumps. And you can shorten the life of the glycol pumps because of your hydrocarbon content.
Well, you're talking about liquid hydrocarbons and foaming issues. So what was what are the main typical causes for foaming in a contact tower?
Well, if you're asking me, I'm going to say hydrocarbons. Salts are pretty bad too, the chloride levels that are in the glycol. People have to realize that when you pull a glycol sample, and I tell my customers, please tell me you're doing regular sampling. And you should be able to look at that glycol sample and check your hydrocarbon content, your pH level, and your chloride level. Those are the three things that are going to affect foaming the most. A lot of things make glycol foamy, and that's not necessarily a bad thing. When you have some frothing of the glycol, then you're expanding surface area, and it helps the gas and glycol come in contact and help dry the gas. But when you pull a wet glycol sample coming back from your tower, it's going to be foamy because it's a mixture of gas and glycol. Mm-hmm. But it should settle to a solid fluid in 45 seconds or less. That's a stabilization test of your wet glycol. Now, I've pulled samples before that look like shaving cream, and 2 or 3 minutes later, it still looks like shaving cream. That's foaming glycol, and that's going to cause you to lose glycol over the top of your tower. So, foaming is not necessarily a good thing, but it's not the worst case scenario if it settles to a solid fluid in 45 seconds. That's what the laboratory does when you send a glycol sample in. They make it foam and then watch it settle down. And you can do that in the field too. You can take a sample container like a Pyrex glass and pull a sample of your wet glycol return, set it on a skid, and watch your watch and see in 45 seconds or less if that's solid fluid.
Well, that's what, so for Chris, it says, are the heavier components the usual suspects, C4 pluses? Or when we talk about liquid hydrocarbons, what are the usual suspects?
Yeah, it's usually going to be heavier than that. C4 would be butane. So butane really shouldn't be absorbed in the glycol. It's like some of the heavier hydrocarbons, like your C8, C9, C10, when it condenses, it'll pull some of the lighter stuff with it. That's part of the beneficial with like a JT unit. That's why you're able to get a bunch of propane out without actually getting to the temperature that propane would normally be a liquid. So the heavier stuff can pull some of the lighter stuff with it, but normally you'd be looking at more of like the gasoline level components that are going to be able to condense in the tower. Something that's going to stay a liquid at maybe like 100 degrees under pressure. So the really it's more like C6, C7s that are getting through there. And to kind of expand the foaming really is the mechanical foaming, there's chemical foaming. So when Terry says you see something like shaving cream, that's more likely a chemical foaming that can keep that foam as a foam for much longer. So like typically if we see something like that, then it's usually not like a particulate that may be causing that, but usually just falls out pretty quickly, but some sort of surfactant maybe that's causing that to happening. So soap sticks, liquid surfactants that are used to lift the wells, detergent that's in the compressor oils. So most compressors run the same oil in the compression and the engine side. There's usually a detergent additive in engine oil. And that detergent is a foamer. It's helps lubricity with the engines, but it doesn't really help anything else once it gets sucked up in the gas. So detergent oils can definitely create foaming problems.
That's a big thing. When I started working for Exterran, I worked at Exterran for 17 years, and one of the first things I did was go to the compressor managers and ask them if they're using high detergent oils and to stop it, and to find out what the gravities of the oils were that they were using. And, you'd be amazed what people inject in a well stream from the wellhead all the way to the dehy. And if you look at a location or a flow chart of a well, they're dropping soap sticks, they're injecting anti-corrosive agents and all kinds of stuff from the wellhead all the way to the very end of the line where it goes into the sales pipeline. And the last vessel is that contact tower. So if some people don't have a coalescing filter separator to capture that stuff, and when you're injecting corrosion inhibitors and all these different chemicals, scavengers, and all this stuff, the only way to get that back out of the gas stream, because we're atomizing it when we're putting it in, so we're making it attached to that gas molecule to do its job. So the only way to get it back out is to put something in the pathway with a micron smaller than that. So, like you were saying, Chris, with lube oils and stuff, you got to have a 0.3 micron filter to capture those lube oils. And a lot of times they either don't check the filters or don't have the right filter elements. And that's where some consulting with somebody would help you. And then they wonder why their glycol is staying nasty all the time. You have to have something in the pathway of that gas stream to stop that chemical flow. I mean, you injected it in there, but you got to get it back out. If not, you will find it in your glycol samples.
Well, like we were talking about injection, Javier asked a question from us. He said, everybody does things differently, but where are you typically seeing methanol over injection upstream of a dehy tower? Is it primarily in compression?
So usually the primary injection point for methanol, they're going to put it right at the wellhead, just to make sure that they're covered all the way to wherever they're going. Where we've seen instances of over injection where there's just way too much going in is they put it right before where they had a problem previously. So like we've seen freeze ups up in Pennsylvania, like right before the dehy vessel. So like it made it all that way, and it froze up right there, most likely because it was cooling after the line heater, and so that just happened to be the coolest point before the actual dehydration. But we've seen it where they're injecting like 10 gallons a day of methanol or something, and like 1 million or 2 million worth of gas, and that's just because they had a freeze up. They set up the pump, they set up everything, and the closest injection point ahead of it, and they're over injecting because they're overcompensating for a problem that they previously had. But for hydrates, you're more likely to have a hydrate at a higher pressure than a lower pressure. So if they're injecting it, the compressor will actually knock out a lot of the methanol. It's got a bunch of scrubbers and everything else in there. Some of it's definitely going to still carry through with the gas. But if they're injecting after compression is usually the place where you more likely need it. So they have to get it, and they're going to do it right after whatever that other equipment is. Usually not right before a dehy unit.
I see a lot of times people have, and it's not just methanol, but that's a good example. It's a very good question. A lot of people have set their injection rates, and then their flow rates change, and they don't change their injection rates. You got everything going in when you're processing, say, 10 million cubic feet of gas, and then your flow rates drop off. Your injection rate of chemicals should also fall off with it. And many times, they've got these bulk tanks sitting out there with the pumps hooked up to them, and they're injecting scavenger, corrosion inhibitor, methanol, whatever it might be. And when their flow rates change, they never seem to go back and adjust the flow of the chemical. Right. So you're over injecting because of that.
And a lot of chemicals have methanol in them as well. So like when we run scavenger, we have methanol in the scavenger. Some corrosion inhibitors will have methanol added into it as well. So there may already be methanol being injected throughout the year, even if it's, you know, not the, usually a winterized blend of chemical has more methanol in it. But yeah, you may already have methanol coming into the system.
To keep the topic going, I'm going to move on to the next topic right quick. Glycol maintenance. So we had a series of questions coming through, and I know we talked previously about filtration, proper glycol maintenance, but I really want to kind of recap the tips and tricks y'all have for proper glycol maintenance. So Chris, you want to kick us off?
Yeah, I mean, the big thing is change your filters. I mean, I'm a big fan of a coalescing filter ahead of the system. Like Terry was talking about, you know, it needs to be the right filter. If you do have something like detergent compressor oil, 1 micron is not going to be able to remove that. Even a standard horizontal with the filter vendor is calling a 0.3 micron may not even remove it if it's a cheaper filter. But yeah, I mean, filtration is going to be a really important part of, and it's the first step in maintenance. I mean, obviously you look at the unit, see how it's operating, see if there's any red flags, but if you're just doing maintenance, I mean, the filter change is really something that should be done regularly.
It's amazing to me. Sometimes I'll go to a location. I was on a site a few months ago, and the guy was upset because he was going through so many glycol pumps. So we met on location. And of course, you know, I'm always like, have your operator meet us there. And we started looking at the filters. And the first thing I do is look at the Y strainer, if there is one. And we opened that Y strainer up and the screen was gone. And I knew it was going to be gone. They're always gone. So, and I asked the operator, where's the screen that was in this Y strainer? And with a straight face, he said, well, I took it out because it kept getting plugged up. It's supposed to get plugged up. It's its only job is to get plugged up. And, you know, they had a canister with 4 filter elements in it, and there was only 3 in it. So there was an open hole. You know, you're starting to see the picture here as to why he was going through so many glycol pumps, because there's no filtration going on. And that pump, you've got very tight tolerances between that piston and the cylinder. And, you know, friction meets temperature, and temperature will burn up and scar those cylinders. And pretty soon you're stroking, but you're not pumping. And it goes back, like Chris said, changing those filters. But also I think the best part of what he said was the quality of the filter. You know, filters are not an expense. They're part of the process. It's just like glycol. You don't try to find the cheapest formulation of glycol. You know, the reason we use triethylene glycol is because of its flash point and the way its hygroscopic properties to absorb water. The reason we buy a good filter element is because if it says 0.3 micron, it's a true 0.3 micron all the way through. I tell people occasionally when you're changing filters, take that filter and saw it in half and look at it.
Right.
See if it got dirty all the way through that element, or if it plugged up, you know, the first half an inch through that filter element.
Well, I agree. By far, the most important piece is going to be filtration. And I think what I would look at after that would probably be just look at any leaks. I mean, if you have leaks happening, you have problems. And then you have to continue looking at your piping system, look at your reboiler. I mean, we received a dehy one time that I don't think it was ever opened up for the life of it. I mean, it was worse than the pictures you would be showing here in a little bit, Cameron. And it just, you already had contamination. It was dark. You had a lot of scaling. You know, paw rings were not existent. So just part of the maintenance is to at least be able to look if you have any leaks or coloration happening. Then you need to be looking at all the details, your filtrations, your reboiler, and whether it's heating and maintaining the right temperatures and what have you, your steel columns, and then moving on to your contactor.
That's right, because people realize if you have a leak, you're also sucking air in the system. Yeah. Glycol in the presence of oxygen becomes very corrosive. And
very corrosive.
Yeah, you're changing everything when you have a leaking fill cap or a packing gland leaking on your pump or something in the system that's letting air get in is letting the glycol become very corrosive.
Well, we actually had a question come through. It says, I've seen several combinations of locations for the charcoal, sock, and also one of those long, skinny Nawada filters. Typically, I've seen on the sock and charcoal downstream of the pump gas separator, which works fine. However, some places do and some don't add the Nawada filter on the rich return side of the glycol pumps. I think it's a good protection for the pumps. What do y'all think?
So the one he's talking about would be what we call what we have labeled as a particulate filter 75 micron, the one like right after the contact tower.
Okay.
So we don't ship a glycol unit that doesn't have that filter on it, unless we are like specifically told by the client that they do not want to protect that Kimray pump. And I don't know why so many glycol units don't have them. I mean, it's labeled as an option for most manufacturers, but I think that one is critical to keeping that Kimray pump working. I mean, a strainer can help. I mean, the strainer is like minimal, in my opinion, but having that filter there, I think is very important to have to protect that Kimray pump. And then really there's another one on the lean side too, just to protect both inlets into that Kimray pump to make sure that nothing, because if you get degradation products in the regenerator, you can get solids created or flakes or something burnt stuff that goes through, and that'll have the same scratching problems that'll ruin up your seals on that Kimray pump coming through the lean side, even though it's supposed to be clean.
I tell people all the time, if you want to know how good your filtration system is doing, is just take 2 mason jars and some coffee filters and take a sample of your glycol after your filter and pour it across that coffee filter into that second mason jar. And then take that coffee filter when you're done and just set it aside and let it dry out. You will see paraffin start to form. You'll see the staining and some particulates gathering up on that filter. And, when you look at the activated carbon and the particulate in line with each other, I've seen them both ways. I've seen some people say they want to put the particulate so that you don't get the particulates in the carbon. And I've seen people say that they want the particulate after the carbon because some of the fines from the carbon can make it downstream. So it doesn't really matter either way. It's just I've seen it both ways, and one's not right and one's not, it's not one right or wrong. It's just different ways. But the most important thing is the filter after the tower before the pump, because everything in the glycol that's not glycol came out of that contact tower. Yeah. That's the only place contaminants can come from. The dehy unit does not create dirt. All the salts and dirts and hydrocarbons, everything came in because the coalescing filter, if there is one, didn't catch it. Either because the filters haven't been changed properly or they're not the right micron. For some reason, you had a separator, let's say, carry over some produced water into the contact tower because maybe the separator wasn't sized properly or the controls weren't set. It carried over produced water. That produced water makes it to the coalescing filter and into the contact tower. The glycol's job is to absorb that water. It makes its way through the reboiler where we flash off the water, but all those particulates and solids stay behind in the glycol stream unless we have a filter to catch it. And if you have 100 micron filters on that dehy, you're not catching anything. You have to have the right micron for the contaminant you're dealing with.
Well, we actually had a question come in here. It says, aren't you worried about the rich filter pressuring up its ahead of the flash drum? Could hydrocarbons in the rich glycol degas in the housing?
So yeah, that's a concern. I mean, if you, we actually had that filter clog on one of our little amine plants recently, and it stalls the glycol pump out. I mean, if that filter clogs up too much, I mean, it's not gonna pressure up, it's just going to drop the pressure on the downstream because you have a differential across the filter. If it clogs completely, it'll clog off the whole housing. It's a high pressure housing, so it's designed to whatever the contact tower is designed to. But if not changed regularly, it will just stall your pump out because it'll clog up. And I mean, the reason we had it happen on ours is because they switched to the wrong defoamer, and they got a cheaper defoamer that turned to jelly in the amine plant, and so the whole thing was just caked up with what looked like yogurt. But yeah, that filter is a very important thing to keep clean. Like Terry was saying, I mean, if you could choose only one place to put a filter in this whole system, I would put it there. Terry would probably agree to put it, before the Chemray pump. And as long as you're keeping that one changed, at least it'll keep everything clean, going further down.
Yeah, I've had so many units that, customers ask me when we go clean a system and we tear it apart and look at it and we pull those fire tubes out and we look in the bottom of that reboiler under the fire tubes and there's 3 inches of solids. And people say, where did those solids come from? And I say, that came into the contact tower with the gas stream. Gas is carrying, we've got to remember, gas is coming out of the ground. It's coming up through the well bore, and we have to put sand separators on it sometimes to capture the sand. That gas is bringing solids with it, and it's bringing hydrocarbons, it's bringing water, and it's bringing anything else that we injected into it, bringing it downstream. So that the coalescing filter is important, and the particulate filter on the wet glycol stream, to me, is critical. It's critical that has the right micron, and you don't want it too tight because then you'll have to change it every other day. But you want it where it's catching the big stuff.
Right.
Then you put a smaller particulate filter on the suction to the pump to capture anything that might be coming out of the reboiler itself. Yeah,
and to kind of jump back to Javier's comment, he was talking about where the carbon filter ends up in the stream of things. The carbon filter really needs to be after the flash separator. And if it's not really worth putting a carbon filter on a glycol unit that does not have a flash separator, because if you have oils and condensate that are coming through the system, they will just completely overwhelm the carbon filter. So it really does need to be after the flash separator, or else you're just using up carbon. One thing though, on the smaller glycol units, the way that they do the heat exchangers on those, they don't do a preheat and then go through the other filtration separator like the bigger ones do. The bigger ones, they preheat through like part of the exchanger, and then they go through filtration, the separator and the filters, and then they go through the main heat exchangers and then the reboiler. On the smaller ones that use those plate style exchangers, they just go straight to the heat exchangers, which aren't great, so they don't quite get the same temperature reach. And then they throw a charcoal filter after the flash separator. They go real hot in the flash separator, which theoretically would aid separation because you're going to flash a lot of the oils instead of keep separating them out as liquid. But you can't, a carbon filter won't absorb really past 160 degrees. Depends, I think, a little bit on the type of carbon, and I'm going off of what a charcoal vendor told me. So I'm trying to remember this, but some of them are lower than that. Some of them really, once you get past 140, the absorption starts to decline on it. So if you're going at 180, 200 degrees through a charcoal filter, it's not doing anything anyway. It's acting like a particulate filter if your particulates are big enough to get caught in it. But really, as a charcoal filter, it's not doing what its job is, which is to absorb the impurities, the heavy hydrocarbons, heavy metals, anything like that, that may cause the worst types of foaming.
Well, to keep up on time, what I want to do is kind of go to the third section that we have. So this is a glycol regenerator. So Terry was in a very giving mood. So he kind of gave us what his multi-point inspection, his service team does. So I kind of like to take the lead, Terry, if you don't mind, kind of walk us through what you have here.
Well, this is what we send out to, for customers to use. The technicians use it as well, but it's really a good tool if you have a customer that's calling you about a troubleshooting issue with a dehy, you can send them this and they can fill this out. You can both look at it and speak intelligently about the same piece of equipment, because you won't have to ask all the redundant questions about what's your inlet temperature and pressure, you know, what color's the glycol in the sight glass. It seems like a very elementary question, but it's critical because that tells you a lot about the condition of the glycol and the condition of the filters. Your glycol is dark and black. I mean, it should be clear to amber. Once it starts getting bluish and black, there's a charcoal issue. There's a problem. There's a problem with the contamination of the charcoal. You know, there's a filter issue. Something's going on with the system. So you have to go through and figure that out. The clean outs every 4 to 5 years, we state that on there because most of the times that's what you want to do. I have some customers that clean them yearly. Reclamation, some people believe in them and some don't. We used to run reclamation units constantly, and we had customers that swore by them, others that didn't. But it's very important to go through a consistent checklist. And the reason we use this is it's the same points every time. We're checking the same thing every time.
The quarterly TEG samples, do you actually have customers? I mean, a lot of our clients are usually wheeling and dealing and being busy, but quarterly TEG samples, do you see them actually pulling those samples and analyzing them?
We always tell the customers how important that is. And not only to pull your quarterly samples, but to sit down as a team with your operators and go over them. Talk about your hydrocarbon levels and your chloride levels. And we talked last time we did this of something simple as a litmus paper to go check a pH.
Right.
You know, empower your operators to go out and know what their pH of their dehy system is, because that's critical to the corrosion level, foaming, and so many other things. The quarterly samples are critical not only to know what's going on right now, but to trend that out over the year, to look at your samples. Where are your chloride levels from last time you checked? Are they going up? Why are they going up? Your pH levels are dropping. You're becoming corrosive. Why is that? I know when your pH level starts dropping and your glycol starts getting corrosive, you're going to see your iron content rising, because you're corroding the inside of that vessel and you're eating it up. All those things are going to combine to tell you what your current condition of your glycol system is. And if you check the same 20 or 22 things every time, then you're going to have a good synopsis of what is going on out there at the Smith #1. How was it last year compared to this year? And you start getting into what I think is probably the most critical point is predictive maintenance. You know, we haven't cleaned in 3 or 4 years. Our levels are going up. Our glycol is getting darker. Let's schedule a clean out before we have a failure.
The TEG reclamation, I mean, what does it just, y'all go through a series of filters, cook it off, or do you have a trailer crew that brings?
It's a Pacer. It's made by Cimarron Energy. It's called the Pacer unit.
Okay.
It operates in a vacuum and it cleans it, recycles it, and then blow cases it back in the unit. It's a distillation system. So it's cleaning the glycol and putting it back in the same system. You don't have to shut the unit down. For a normal clean out, you're shutting it down, shutting everything off, and cleaning it. For a reclamation, you basically back the trailer up to the dehydration unit and hook it into the connections where the glycol goes into the steel column, and you're recycling it back to the reclamation and then putting it back in the dehy while it's in service. And the blow case counts the dumps that it blow cases off. And if you know how much the blow case is putting out every time, the counter tells you when you've turned over the complete amount of glycol that unit holds. So reclamation on a little small unit, like a 500, you could do in a day or so. A big, large unit, you would have to have it running for days to let it reclaim that glycol in the system. And when you're done, your glycol is clear like it was when you started. Now, the problem with it is, and my problem with reclamation's always been, you're cleaning the glycol, but you're not moving the solids that are under the fire tube.
Right.
And you're not getting the solids out of the tower. So when you move that reclamation unit off location, after a couple days, it's going to come right back to being where it was if you didn't get the dirty stuff out.
Well, we had a question come through. What is the typical service life of a unit with proper maintenance? I mean, one of our companies, we got hundreds of glycol systems sitting in our yard. I see contact towers, but the reboilers I never really see. So Chris, I mean, what do you see on that?
I mean, I really think it depends on how that unit was built originally. I mean, there's certain areas of corrosion that Jesse, I know you've seen that, certain things that shouldn't be as thin as some manufacturers make them. Certain units that show up that have no filters on them for some reason when they left the original manufacturer. I mean, with a unit with proper filtration, if you have a good coalescing filter, a proper sub-micron reverse flow coalescing filter ahead of your glycol unit, and you're running low micron glycol filters and charcoal filtration on your system, you're keeping your temperatures in check, you're not letting your reboiler temperatures get too hot to where you're seeing those degradation products with the glycol. I mean, you can run for the same unit without having to do a reclamation or clean out for up to, maybe 10 years or so. If you're, replacing the parts properly and keeping the filtration properly. I mean, realistically, or theoretically, you could perpetually run a glycol unit as long as there wasn't corrosion that you're worried about physically eating it. You could continually run it. Eventually, you will need to change out your glycol, which the reclamation, it's getting rid of the degradation products of the glycol is the big thing. I mean, it is just also a large filter to clean the system out. But if you're not overheating your glycol, which is a very tricky thing to do, especially on direct fired reboilers, because the fire tube film temperature can get hot enough to where it's just slowly degrading a little bit of glycol. If you get standard glycol over 105 degrees, it's going to start degrading, and that will build up. It can build up as a solid, it can turn into a goo or chunks that can clog up filters. But if your filtration's removing it, then you're removing that degradation product. Reclamation is going to get rid of all of that bad TEG and leave you with just the good TEG that's in the system, so that you can keep running the same system over and over again for years, as long as it had a good maintenance cycle without having to do these big clean outs. I mean, obviously, like facility dehyes are, they're not subject to the same abuse that the field dehyes go through. Facility guys, they're there maintaining that stuff. They have to see the same units every day. They understand how they work better. The field operators, you may change those guys out every 6 months. They're just, there's not someone standing next to that glycol unit all the time. And because they're just so much closer to the well, like Terry said, there's just so much stuff that could come into that unit when it's back, in the field. So you have a lot more problems, higher CO2 levels that you wouldn't have to deal with further down the line, or maybe even some H2S that nobody thought to check for, or corrosion inhibitors that aren't the right kind or something. So, those field dehyes, I mean, they may not last nearly as long just because they're just not maintained as well. And sometimes it's a cost thing too. I mean, you can pay to have more filtration. You can pay for WPI to come out there, every month and do good service to it, or you
Amen.
can, or you don't, and you save a bunch of money until the unit just implodes.
Well,
it's good job giving props, Chris. I appreciate it.
There you go. Yeah. No, it is critical. I tell people all the time that a lot of times I'm teaching a customer to maintain their system so they don't need us as often. We used to have in Odessa about 35 units that we did monthly maintenance on every month. Filter changes. We did this 20-point checklist, everything, you know, and that way they had predictive information. We don't do that anymore because we taught the operators to do it, and they take care of those units now. But, you know, the charcoal filters and stuff like that, that's critical because that's going to tell you the condition of the system. Keep those filters changed. And, you know, I've seen units that run for, you know, we just cleaned one the other day that was built in like 76 or 77. Mm-hmm. It's been out there functioning for 30, 40 years, you know, by itself, just kind of plugging along. Same reboiler, same fire tube, same contact tower. What's changed? Glycol, filters, and pumps. You know,
well, Jesse,
the consumables.
Jesse, you've, I mean, we've shipped several towers for you to repair and kind of get back up into working shape. And I guess the oldest ones that we've shipped you is early 80s or something. Mm-hmm. Structure pack and trays. And so I make it, you just see, as long as they maintain it, I mean, you're the one ripping it open. So you just see quite a few issues with that.
Well, I think by the time I get them, then, you know, obviously there wasn't enough maintenance or checking. I like what we're seeing here, and especially what Terry has, is if you start with these conditions and you're monitoring over time, then you're going to know when something changed, right? So if the folks in the field understand why, you know, something is being run at these conditions, and if your temperature is going higher, then how it affects, you know, your glycol circulation and regeneration, et cetera, then your equipment is going to last a lot longer. But if you don't know, or they're not trained to understand what they should be monitoring and what they should be maintaining, then, you know, they might not paying attention to it. So by the time we get it, it's pretty in pretty bad shape. Now we've seen, I think the worst pieces that we've seen that are really bad is around the reboiler side. I mean, even, you know, we've done contactors, but I mean, for the most part, contactors could have been something that wasn't, you know, just overlooked or were not really done right from the beginning. And then, you know, on times you'll see that the trays were just plugged. You have a bunch of corrosion because either fouling of hydrocarbons circulating through the reboiler and what have you. But the reboilers, for some reason, I mean, you know, I guess it's just too much work trying to take them apart, pull the tubes out, and kind of monitor how things are internally. The other piece is, you know, we talked about earlier where the installation side is if it's not sealed and of course that insulation absorbs all that moisture and holds it, then, I mean, it's just around those flanges. You'll start seeing all that getting corroded externally even before the internal part is corroded. So I think it all goes back to, I mean, this to me is when I saw it, is a very good tool to have, because you'll start monitoring at each piece, critical piece of your dehydration system, where it should be and where it's at. And then if it's not where it's at, then something changed, whether it's maybe the original operating condition or design conditions, or you have issues with some equipment, or you're getting air, or you know, or you have contaminated glycol. You know, I think this is, to me, is kind of like having safety systems in place. You know, you have a high level, boom, you get an alarm, you know, so this is excellent.
Well, Tony Brown said he's personally worked on units, glycol units, as old as the 1960s, but that's with proper filters and cleaning. So he had that caveat in there, proper filter cleaning. But Drew Gibson, this is the last question for this section, but he said, I see under item number 17, change date of charcoal canister. Is there a frequency of replacement that you recommend? Do you see many customers pre-washing their carbon elements before putting into service? Chris, I mean, you've talked to several vendors on that. So what do you say on that?
So the pre-washing of the carbon element, the only reason I could see to do that is really, it's like if there's the carbon fines, like the little tiny bits of carbon that may have sheared off just from shaking the canister around or something, the idea would be to, I guess, wash those off. You really shouldn't have any other contaminants that are on the system. I mean, the canister should be clean enough that you're not going to introduce anything negative into the system. The carbon fines is really the only thing I can think of that may be the concern of why you'd want to do that. I wouldn't see any reason to do that if there is a filter after that carbon filter. So, which is the typical way that we build them. When we build them, we have the carbon filter, then we have the particulate filter right after it. I mean, those like the standard Jonell or Pico canister type ones with the loose charcoal in them. I mean, those, like, they're inside of a cotton sack basically. So the fines really shouldn't leave that. They definitely could if they're small enough. But really, I wouldn't really see that as a big, concern to have to do that. I mean, it really should get picked up. If they're going straight to the reboiler after that, then they may end up in the bottom of a reboiler or build up in a heat exchanger or something, which may necessitate a clean out. But you're not really introducing a lot by having that.
When would you choose change them out? What tells you the frequency?
For changing it out, it's like, and I know Terry's talked about it, is the simplest way to do is just pull a sample before and after that charcoal filter into a small glass jar and shake up both of them and look at the foam head that you get on top of both of those samples. If you have a noticeable difference in foam on the inlet sample versus the outlet sample, the charcoal filter, then the charcoal filter is doing something. If you shake them both up and they both have foam equal amounts that's not really falling down like it's supposed, like it should just settle away, then that charcoal filter is not doing anything anymore. Of course, pulling these samples and changing it, that you could figure out the optimum time to change those filters out, but those charcoal filters really aren't worth that much. I mean, the best thing is just get into a groove of, say you're going to do it every 2 months and just change them every 2 months. Or do it every month if you're seeing them where they're not absorbing like they're supposed to sooner than that. But like, figure out what a good schedule is and just stick to a schedule. Is better than trying to like shake them up and be like, oh well, Tim didn't shake them up enough. So
I tell guys to watch number 10 because the color in the sight glass is going to tell you hydrocarbon content, and usually that tells you by that time you've already not changed them. You've let them get saturated. It's kind of like an aquarium. You have a charcoal filter in your aquarium that absorbs ammonia from the fish waste. When the filter gets saturated, your water starts changing color and you get algae growing in your tank. Change that filter and your water cleans up. Same thing happens in a dehy. When you change your charcoal filter, you'll notice your glycol and your sight glass cleans up a little bit. When it's funny, they talk about, I remember, and the old fart in me kicks in here, because I remember when we used to have to dunk them, we'd take a 5-gallon bucket and we would dunk the charcoal canisters because the charcoal, and I'm going way back here, was not activated. You notice nowadays they say activated carbon, but back in, a long time ago, 25 years or more back, it wasn't activated carbon. You had to activate it by submerging it in water. I don't know why, and you would get a lot of fines out of it. That whole bottom of the bucket would be just full of dust off the charcoal. And I'm assuming it was a different kind of charcoal, a different kind of carbon, because it wasn't activated, what they told us at least, who knows. It wasn't activated until you dunked it in that water and then drained it out. And then we thought it was crazy because we're putting water in a system that's supposed to be getting out water. But that's what they always told us to do. And then when they came out with activated carbon, you didn't have to do that anymore. But that's why originally, like the old units, the old Smith systems, they had the reason they first put the particulate after the carbon was to catch all those fines that was in the charcoal canisters. That's just 2 cents from an old man.
Yeah, and they do make new charcoal canisters that are it's just a solid block of carbon. So it's like just a giant tube of carbon. It's not solid; it's porous, and the glycol can go through it. But you're dealing with one giant hunk of carbon instead of the canister full of the fines. Like we sell those and install them in our, like on the real small glycol units, like the one pictured there, it's like a little 125 reboiler. We use those in a water housing instead of having a dedicated canister, because it's a bigger canister to have to put on there. We just put the Nawada housing with that solid carbon filter in there, which you don't have to deal with fines because it's one solid hunk of carbon. Because it is a finer filter, though, it's also a 10 or a 15 micron or something filter. You do have to change them out a little more often because they will get plugged with particulates if you're not filtering good enough ahead of it.
Well, we're not going to have time for the fourth one. The fourth one was emissions controls. So what I'm going to do is we're going to pass that on to next month. We're going to fully explain that, talk about that. But to kind of wrap this up, I'd like to talk through these examples, and then we'll start wrapping this workshop up. So, Chris, you took a lot of these pictures, so kind of walk us through these.
Yeah, so this is, you can see the scaling on the fire tubes. This is the fire tube that was pulled out. And you can see like the giant flakes that have come off of this fire tube. Obviously, this isn't as bad as it could be, but there was a lot of stuff that baked onto this fire tube that it was either them running the temperatures too hot and cooking the glycol onto it, or impurities in the glycol just cooking onto the fire tube and causing that coating on it, which reduces your burner efficiencies on it. The other pictures are a fire tube. So this is what Terry talks about when he says, they come out and they clean your fire tube. This one, I don't know how long this one was in service for, but there's just a tiny hole through what is an 1.5-inch pipe is now completely clogged off with soot because the burner wasn't optimized for its burning, and it's nearly completely clogged off. So, I mean, this is, I'm not even actually sure how the soot even made it back in there. It should just be gas blowing through this thing. But the fire tube, I mean, it's nearly ineffectual. With this clogged up with dirt and grime, and I'm sure Terry's seen examples of burners that look even worse than this.
Well, that's the whole reason for doing the burner checks as part of your winterization, is to get all this stuff ahead of time, and that's contamination of your fuel gas. Whether it be water or hydrocarbons, it's liquids. And that orifice gets plugged, now you're restricting your burner. I tell guys, when you have a burner that doesn't seem to burn very well, take your adjustment needle for your fuel gas and run it all the way in till it's shot, till it stops, then back it back out. Sometimes you can break that little plug off in that orifice and it'll start burning better.
Absolutely. The next set was, again, these are pictures, Chris, that you took. So,
yeah,
the one on the right,
maybe Terry's.
That's Terry's.
Yeah.
So
yeah, that's some bad scale buildup. The one on the left is that's from a fire. They had to carry over out of the still column, and you can't see the pipe anymore, but there was a pipe attached to the still column that angled over, and so it that hot glycol, either just a really hot glycol or most likely it had a bunch of hydrocarbons in it that boiled over, caught fire enough to melt the aluminum off of the reboiler there.
The one on the right, Terry, what happened here?
People ignoring the maintenance on the dehy, lube oils, other contaminants, and just ignoring it over time, and then letting it overheat, and you can see it just started flaking off. And what happens, people don't realize that when you get a coating on your fire tube like this, you're affecting the thermal properties. The heat can't transfer through that pipe anymore, so inside the fire tube you're becoming overheated and you're creating hot spots on the fire tube. And then when that dirty glycol comes in there in the steel column and pours on top of your fire tube, that hot spot's attracting those minerals, and it just a domino effect. And pretty soon, I've seen the fire tube covered in 3 or 4 inches of that stuff. And then over time, the fire tube just collapses upon itself, and you have a fire tube failure.
Okay.
Well, and I think the failure would be, the worst case would be that you would start having holes or buckling, and then you have fires happening.
Yeah. Yeah,
Absolutely.
So the biggest thing on, I guess, throughout this was proper maintenance. Emission control, man, I was really wanting to touch base on this, but we'll expand this out for next one, especially with the new possible administration coming into effect and then the EPA coming in. If we join the Paris Accord, there's going to be a lot more emission control issues. So we were wanting to talk about upgrades, things that we're seeing in the past, but we're going to pass that on to the next time's webinar. But on the recap on this one was proper maintenance, filtration, looking out for liquid hydrocarbons, taking samples, identify all the parameters that Terry had in here. So if you're interested in being a webinar speaker or know someone that wants, that would be a good fit, please reach out to tori.valagura@croftsystems.net. Please give us a feedback. The only reason we're doing this, I mean, we got 2 CEOs, director of engineering, and then we got a manager that runs a whole company right now on this. And all we're trying to do is share the information. So we want to make sure this information is coming across properly. So please give us feedback of what would you like to see, spend more time on this. Do you like what you're seeing? Do you want more visuals, more images? Just let us know and you'll get a free hat or shirt. If you have anything after this, you want a follow-up call with your team, we've done it in the past where we brought in several engineers. We go on a Teams channel, Zoom call, whatever it may be, just to kind of really focus on our clients' issues or what the big initiatives that they're trying to do. Please let us know and we'll make sure we get Terry on the phone call, Jesse, me, Chris, whatever we need to do. So please reach out to me if you got any questions on that. So we're going to wrap up this webinar, but Jesse, Chris, and Terry, I appreciate y'all spending the time and coming on and talking with us.
My pleasure.
Always fun.
All right, guys, I appreciate it. And thank you for all those that attended us, and especially asking those questions. I thought they were fantastic. We answered 12 questions today, so I appreciated that. All right, well, I'll see y'all next month then.
Be safe out there.
All right, take care, guys.